Problem number 10. A parallel plate air-filled capacitor having area of 40 centimeters square and a plate spacing 1 millimeter is charged to a potential difference of 500 volt. Find the capacitance. That is our first question. And the second question is find the magnitude of the charge on each plate. And the third question is find the stored energy. And the fourth one is find the electric field between the plates. And the fifth question is find the energy density between the plates. So first of all, let's rewrite the given first. So you have an air-filled parallel plate capacitor and the plate has an area which is 40 centimeter square. So 40 centimeter square in terms of meter, which is 40 multiplied 10 power minus 4 meter square. Clear? And then we have the space between the two plates. So what is the distance between the two plates? So D value is 1 millimeter. So in terms of meter, 1 multiply 10 power minus 3 meter. And how much potential you set across these two plates? V, which is equal to 500 volt. If you want to see the figure, so you have two plates. So plate 1 and plate 2 you have like this. And you set the potential between the two plates as 500 volt. When you set potential, the charge will stored on each plate. By that you have the electric field between the two plates and the distance between the two plates is 1 mm. So later on we are going to use this mm value in terms of meter, and also the area value is given and how much potential you set 500. And by using all this, in the first part we are going to find the capacitance value. In the second part we are going to find what is the charge stored on each plate, and the third question we are going to find the answer for the energy stored in the plates, and the fourth question we are going to find the answer for the electric field between the two plates, and then we are going to find the answer for the fifth question. So this is D and this is E, right? So in the fifth part we are going to find the energy density, E small u. So there is a difference between the third part as well as the fifth part. Third part we are going to find the answer for the energy stored in the plate, and the fifth part is the energy density. So energy stored should be denoted with the letter caps U, and the energy density is denoted with the letter small u. Clear, brother? So we are going to find all these five answer for these five questions. So let's apply the rule one by one. First question, we are going to find the capacitance of the parallel plate air-filled capacitor, as we already studied in the theory. C, which is equal to epsilon naught A over D. And the epsilon naught value is a constant, 8.85 multiplied 10 power minus 12 multiply the area is 40 centimeter square. So 40 multiply 10 power minus 4 divided with D, which is 1 millimeter. So 1 multiply 10 power minus 3 meter. So let's see what is the answer. I have to calculate this. Just a minute. 8.85 10 power minus 12 multiply with 40 10 power minus 4 divided with 1 10 power minus 3. Here I got the answer as 3.54 10 power minus 11 farad. So 3.54 10 power minus 11 farad. So this is the answer for the first question. In the second question, we are going to find the charge stored in each plate. We are going to find the charge. So for this, I am going to use the equation of capacitance equation. What is the capacitance of the capacitor? C, which is equal to charge over potential. Therefore, charge which is equal to the capacitance multiplied with the potential difference. So now, for this capacitance, I am going to use the answer in the first part. And the potential you set across the plate is 500 volt. So I'm going to use these values here. I'm going to substitute the value of C, which is 3.54 multiplied 10 power minus 11 multiplied with 500. So when you multiply the answer with the 500, what you get? I got the answer here as 1.77. So charge Q, which is equal to 1.77 multiplied 10 power minus 8, and the unit for the charge is coulomb. So this is the answer for our second question. And in the third question, we are going to find the answer for the energy stored in the plate. In the theory, we studied three formulas for energy stored. You can use any one of the formula. Better, I'm going to write all the three formulas. Energy stored, U, which is equal to half Q multiplied by V. Second formula is half capacitance multiplied by potential square. And the third rule is Q square over 2 multiplied by capacitance. And all these three equations will give the same answer. So you can use any one of the equation. You can see the first equation. We have the charge value in the second part. We have the potential in the question, which is 500. So possible. And the second formula, if you want to use, we have the capacitance in the first answer. We have the potential in the questions. So no problem, you'll get the same answer. If you want to use the third equation, no issue, because charge answer you already identified from the second part, and the capacitance you already find the answer from the first part. So if you use any one of the equation, you will get the answer. Okay, better we can do one thing. Let's check whether we will get the same answer or not. Okay, for sure your answer will be same, but better we can just substitute the value in these three equations. So let's see what is our answer. Clear? So I'm going to use the first equation. So charge value, I'm going to take the answer from the first part, 1.77 multiply 10 power minus 8 multiplied with 500 divided by 2. Here I got the answer as 4.425. So 4.425 multiply 10 power minus 6, and the unit for the joules is unit for the energy is joules. So better I can just round up this value, which is 4.43 multiply 10 power minus 6 joules. Okay, let's check for the second formula. What is the second formula? CV square over 2. So the capacitance 3.54 multiply 10 power minus 11, which we find from the first part, multiply with 500 square, because the potential is given in the question, divide by 2. I got the same answer, 4.425 multiply 10 power minus 6 joules. So if you round it to 2 digit, just 4.43 multiply 10 power minus 6 joules. And if you want to use the third equation, let's check. The charge is 1.77 multiply 10 power minus 8 square, which we identified from the second part, divided by 2 multiply with the capacitance. Capacitance from the first question is 3.54 multiply 10 power minus 11. Again, I got the same answer, 4.425 multiply 10 power minus 6 joules. So I can round it again, 4.43. You no need to round it, but if you need, you can round, no problem. Clear? So if you want to find the answer for the energy stored, you can use any one of these three equations. All these three equations will give the same answer. So this is the answer for the third part. So in the fourth part, we are going to find the answer for, I think, electric field, right? So you can see here, we have fourth question is electric field. So I'm going to find the electric field. As we already know the formula for the electric field. What is the rule for the electric field? In between the two plates, you can get the electric field. So electric field is given by the rule E is equal to potential divided by the distance. So here the potential you said between the two plate is 500 divided by the distance between the two plate is 1 millimeter, which is 1 multiply 10 power minus 3 meter. So here 500 divided by 1 10 power minus 3. I got the answer as 5 1 0 second 0 third 0 fourth 0 fifth 0. That means 5 multiply 10 power 5, and the unit is volt per meter. Clear? So this is the answer for your fourth question. Clear? Okay, only one more question is there. We are going to find the energy density. Again, the energy density, we have two rules. So what are the rules? You already studied in the theory. So the energy density should be denoted with the letter small u. So what is the rule? Energy is divided by, that means the charge, the energy stored in the plate divided by volume. What is volume? So here volume I can write as area multiplied, because we don't have the volume, but we have the area as well as the distance between the two plates. Actually, this area multiplied by distance is nothing but a volume. Don't get confused about the letter V, because voltage as well as volume. Okay, so that's the reason I just use the volume in terms of area multiplied by distance. So we have this rule, and we have one more rule. What is the rule? U, which is equal to epsilon naught multiplied by electric field square over 2. These two formulas we studied. If you use any one of the equation, you will get the same answer. Okay, better we can do the same thing what we did for third part. I will substitute the values in these two equations, and these two equations will give the same answer. So for the energy stored, I have to take the answer from our third part. What is the answer? 4.43 multiply 10 power minus 6. 4.43 multiply 10 power minus 6. 4.43 multiply 10 power minus 6 divided by, what is the area? Because the area information and the distance between the two plates is already given. So area is 40 centimeter square. So 40 multiply 10 power minus 4, and the distance between the two plates is 1 millimeter, which is 1/10 to the power of minus 3. So let's see what is the answer. Okay, so 4.43 10 power minus 6 divided by 40 10 power minus 4 multiplied with 1 10 power minus 3. I got the answer here as 1.1075. So I will round this value to 1.11. And what is the unit? Because the unit matters. So here the unit for the energy is joules over, and what is the unit for meter area? Meter square. And what is the unit for the distance? Meter. So meter square multiplied by meter is meter cube. So that means bottom we have the volume, right? Okay, let's check our answer for the second part. We know the constant value of this epsilon naught, which takes the value of 8.85 multiply 10 power minus 12, and the electric field I have to take the answer from the D part, which is 5 multiply 10 power 5 whole square divided by 2. So let's check whether our answer is exactly matched with the first equation. So 8.85 10 power minus 12 multiplied with 5 10 power plus 5 square over 2. I got the same answer, 1.11. 1.106 I got. So if you rounded the value, which is 1.11, again the unit is joules per meter cube. So that means you can use any one of the equations, because in the decimals you can, here we go, don't get confused. Oh, doctor, I got here 1.1075, here 1.106. It's not a matter, but when you round it, both equations will give the same answer. Clear? So this is the answer for your fifth part. Clear? That's it. Thank you.